Okay, this is the last part of the binomial distribution. Something happened to my recording, and so I'm going to go ahead and just go through what I did without rewriting it. So we've got the national student loan default rate for students who graduated 2013 is 11.3%. If 10 students from that cohort or that group are randomly selected, find the probability of the following events. So this is a binomial distribution. We've got the same experiment. We're doing 10 times with 10 people, exact same experiment, exactly two outcomes. They default or they don't. The probability of success is constant. There's your 11.3, and the trials are independent. They are randomly selected. So we know for sure this is a binomial distribution. Get my camera just a little bit. Okay, so there we go. So that being said, we want to start with the first example, and we're just going to work through everything that we've done on this page. We've got exactly 3 students defaulted on their student loans, so we want to find that probability. So this is what we're looking for. So we have 10, our N is 10. Okay, so we're going to choose 3 students. We've got the probability of default is 0.113, and that is to the same power as the number you choose. And then 1 minus 1.113 raised, and then we subtract these. 10 minus 3 is 7. The other way you can check that is that 7 plus 3 has to equal 10. So when you key that in your calculator, you'll get 0.0747, etc. And that rounds to 4 decimal places in this manner, 0.0748, which is about 7.48%. Students, if you select 3 of the 10, would default on their loan. If you want to not enter this, you can always enter the 0.887. So let's look at this next one. It's a little bit harder. At most, 3 students defaulted on their loan. So out of 10 people, at most 3 did. So that means you could have 0 defaulted. That means you could have 1 defaulted. So 0 defaulted, or 1, or 2, or 3. That's how you mathematically think about at most 3. So we need to find the probability of each one of these and add them, because remember I said 0 students defaulted, or 1, or 2, or 3. And remember that the word or goes with addition in probability type scenarios. So we're going to calculate this one first, 10, and I've already marked out some things, but we'll come back and talk about that. So I have 10 choose 0 times 0.113 raised to the 0, that's your X or your R, and then 0.887 raised to the 10th. So notice 10 minus 0 is 10, or 10 plus 0 is 10. Alrighty, and then so when we get ready to do this, you can already know that this is going to be a 1 and this is going to be a 1. If you haven't thought that far ahead, yes, you can enter that in your calculator. It's fine. So then we need the probability that one of those defaults. I've got 10 choose 1. Follow the same pattern. This is to the first power, the success. This is the failure probability. This is 9. 9 plus 1 is 10. And notice these match. So when we have 2 out of that group, 10 choose 2, 0.113 raised to the second, times 0.887 raised to the 8th. This is 10 minus 2 is 8. 8 plus 2 is 10. And then the 3, 10 choose 3, 0.113 raised to the third times 0.887 raised to the 7th. So on this one, this is the first time I found that I could use this calculator, type everything in as it is, and run out of entry spaces. So I got a big error message. So that's when I had to think, what can I do to shorten up what I'm going to enter? Because you can enter this, plus this, plus this, plus this, and you will get that on your scientific calculator. If you shrink these down to 1, because they do equal 1, it lessens your entries. And if you go ahead and make that difference, that'll help shrink the number of entries. You could also maybe add 3 of these, get your answer, calculate this one, and then add the decimals together. So you could break it apart as many times as you needed to if there was an entry with your calculator, some kind of an issue. Okay, so what we get is 0.980484111, which rounds to 4 decimal places. Okay, so at most 3 students, what's the probability that at most 3 students in that group of 10 have defaulted on their loan? About 98% of them. So the other thing that I did on this problem earlier is I made an error. I put the wrong number here and the wrong number here. I forgot to add these up to see that they made 10. So I put the wrong number, and not only did I do that, but when I got my answer, I had 1 point something. So I got a probability of greater than 1. That's a problem, because probabilities can't be larger than 1. So I knew when that happened, I had a big problem with my answer. So let's move to the C part. I thought this one was I thought it was hard. Okay, so let's think about what that looks like. At least find the probability that at least 3 students of the 10 defaulted on their student loans. So this is what we're looking at. Mathematically, that's between 3 and 10, including those endpoints. But if I do that, I'm going to have to use this scenario and do the probability of 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. And it could be done, but it's really cumbersome. So at least 3, that's on from 3 up to 10. At most 3 is from 3 down to 0. So if I get that part 3 down to 0, that is just the complement of this right here. So I could, to make things easier, less work here, I could take 1 minus the probability of at most 3 defaulted on their loan, which I already have that calculated. But now the problem is, at most 3 includes this 3. At least 3 includes this 3. But when I do this subtraction, I've eliminated the probability for 3, so it has to be added back in there. Okay, so we're going to take this complement, 1 minus. I'm going to go back up here and pick the decimal I calculated, and I'm going to pick all of it so that I don't have a round-off error. Plus, I'm going to have this probability of 3. And I'm going to make that calculation, plus enter this, and I'll get this probability, which is about 9.43% of at least 3 defaulted on their student loan. Okay, just a different way to look at it, using that 1 minus scenario to help us not have to do as much work up here. So let's do this last part. This is what is the expected number of students who default on their student loans? So remember, this is for the binomial. This is the binomial formula for expected value. So what is the expected number of defaults? Well, if n is my 10 and the probability is 0.113, I can literally multiply those together and then get 1.13 students, which is my expected value. So that means in the long run, we would expect on average that 1.13 students will default on their student loans. That is the end of binomial distributions and binomial probabilities.